Today we will talk about object orientation. An object-oriented programming language is a language that uses classes and objects. Uh, C# is such a language. There are some other languages that don't have any objects. Uh, they don't have classes, they just have a bunch of methods, and whenever you make a big program, then it gets really, really messy because you can't sort things into classes and namespaces. Today we will also talk about different ways to uh, play with classes. We will use words such as encapsulation, inheritance, and polymorphism. They are big words, but they signify pretty simple concepts. Let's start with class members. I mentioned this before. There are three different kinds. There are methods, which are normal containers of statements. You can see these as the behavior of a class or an object's skills or as the verbs that it can perform. Properties are specialized methods which change variables. That's pretty much what they do. You can see them as the attributes or the adjectives of an object. And the events get called, are specialized methods which get called by Windows when something happens, when something changes. So they are kind of like exclamations from Windows that we need to react to. Let me show you in code. Here you have two classes, and each class has one member each. This one has an update member, and this one has a draw member. These are both methods. They are not properties or events because we haven't talked about properties or events yet, how they look in code. We will play around with these two members a bit, and the first thing we will talk about is encapsulation. There is something called access modifiers, and they are used when you're collecting related members in a class, and you only want to expose the relevant members. A good example of encapsulation is you, for example. You expose as little as possible. You expose mouth and ears, but you hide lungs and intestines. So if you were a class or an object of a class, an instance of a class, then you would be encapsulated because you only show a few things. And that's what we use the access modifiers for. We can put things to be like internal organs. The default is that everything is hidden, and that is called that it is private. That means that it is only accessible within the class. The stomach can pass things to the intestines, but I cannot pass something to you, or well, maybe I could, but that would be really gross. Another kind of access modifier is called protected. The keyword protected. This one is not the default one. It needs to be explicitly declared. This one means that the members, such as a method, can be used within the class, or it can be used by derived classes. We'll get to that in just a second, what that means. Basically, it means children of the class. Don't worry about that, we'll get back to that later. And the last one today is public. That's another keyword that you need to declare. And that means that the member is accessible. You can call it from any class you want. And even if you don't actually need to type private, because that's the default one. You should probably declare accessibility all the time, because that makes your code clearer what you want to achieve with it. There's an exception, and that is namespaces. As before, they don't affect code, they just sort code into different folders. And since they can't have any restrictions, you can't put an access modifier on them either. If we go back to the code, I can show you what changes. For example, let's add the word public to this one and the word private to this one. If we want, we can call the draw method inside the engine class and draw method. That's fine because the draw method is declared as public. However, if we want to call the game update method, that is not gonna work because this one is declared as private. So I'm going to delete that one. And let's go back to the slides and I'll show you another concept. Inheritance is good because you don't have to call the other class repeatedly if you inherit from it. Basically, you can say like this: if you have two classes that are related to each other, you have a base class and a derived class, then the base class will lend out all its methods and then variables too, for that matter, to the derived class. So you don't need to call methods inside the base class from the derived class because it is as if they were already inside the derived class. Some programming languages call these parent and child, and the code is usually a bit more general in the base class, and then you specialize it in the derived classes because you can add more methods that specialize the old methods. The reason why inheritance exists is because you can keep classes small, and then you just derive from those classes to add, and then you derive from those a second time. So you have a base class that derives from that gives methods to a derived class, and then the derived class has methods that it gives to another derived class, and so on. So you make kind of like a tree structure of small classes, and the code gets clearer to read, and you can reuse a lot of code. So that's a good thing. Let's take a look at what it looks like in code. I'm going to change a few things. Okay. Instead of private, I now have protected there, and then I added something funky down there. This little colon and game means that engine is inheriting from game. Engine is the derived class, game is the base class. In practice, what this means, it's kind of the same thing as if there would have been an update method here, because although there isn't one right now, because the engine class borrows all the members of the game class. That's it. That is inheritance. However, there is a second related concept called polymorphism. So let's do that one as well. Sometimes the derived class has a slightly different purpose than the base class. That's why you derive to start with. And sometimes the methods on the base class that you are borrowing don't perform the things you want them to perform. So you need to change them a bit. And you do that with a keyword. When you declare the method, you place the word override before the name, which means that it replaces the one in the base class. And the base class can also block this or allow this. If you type the keyword virtual, that means that the method can be replaced in the base class. I mean, if you type virtual in the base class, then you can override it in the derived class. If you don't type virtual, then you cannot override. Let's look at that in code. Let's add a little bit of code here. As you can see, the base class is declaring the update method as virtual, which means that we are allowed to override the update method and make a new update method here. So whatever code we have here will not work here anymore. We will have some new code here that will work instead of it. This is a pretty simple concept with a fancy word polymorphism attached to it. Now there is a compromise too. Sometimes you want to use the old update method, sometimes you want to use the new update method that you create, but sometimes you want to just add some code to this one. Let's say that this update method saves the high score, and this method you in the game engine you save the high score, and then in the in the game you save the high score, and then when you derive from that in your engine, you want to save the high score, but you also want to save the time, the amount of time the player spent reaching that high score. And then that would mean that you still want to use the code that was up here, but you want to add some code to it. And there is an easy way to do that. You can refer to that code. There are two keywords. This refers to the instance of this class, and base refers to the methods and the other members on the base class of the derived class of this class. Let me show you that in code. It's much clearer then. I'll add a line of code here. If we want, we can call the base object, the method on the base object, update. So let's say that this one prints the high score, and then after we have done that, then we can add code here for printing the time, for example. So you get the benefit of using the method on the base class, and you can add your own code without losing it. Okay, let's use some of these concepts for real in Visual C Sharp in our game.